Hello and welcome back to SIG Mechanics. I'm Edmund. In this video, I'm going to be talking about the mechanics of the P320 trigger, but not just the SIG Sauer factory triggers. This video will explore and test every single trigger that has ever been made available for the P320. And I'm going to provide subscribers a complete profile analysis of each trigger using professional trigger testing equipment, which I'll tell you more about later, to showcase each trigger's overall travel, take-up, creep, smoothness, consistency, distance to brake, over travel, and more. And then I'm going to take this data and graph it to create a comprehensive reference table. So by the end of this video, no matter which trigger you own, you will know with profound detail how your trigger behaves and performs while it's inside the FCU. Let's begin. Now, I have it on good authority that other manufacturers are currently working on more P320 trigger models, and I may also be working on one myself, but as of the time of shooting this video, I believe that these are all the triggers that have ever been made commercially available to the public. Now, the reason I'm testing so many triggers is because we are not just testing one version of each trigger and just assuming that the variations of that trigger are going to perform the same way. Therefore, even if a manufacturer sells a flat and a curved trigger, but they don't market the two triggers as being mechanically different, we're still going to test both in order to independently verify if there is even a subtle difference between the two. I'm also including something that I think is special, and that is every single discontinued model of the P320 trigger. Now, these triggers you can no longer buy, and in many cases, this is due to the SIG Sauer voluntary upgrade program making them obsolete. But I did feel it was important to include them, both out of sheer curiosity as well as to capture if there is any performance differences caused by the trigger's design changing. That being said, I want to clarify that this video is not a head-to-head competition to see which trigger performs the best, because my intent here is not to endorse any brand or model. I want to remain as impartial as possible and simply provide subscribers with the raw data to use as you see fit. So to be clear, in order to remain unbiased, I won't be offering you my opinions, and I am relying solely on the data output from the trigger testing equipment. Now, on that topic, let me introduce you to the testing device. This is the Trigger Scan, a German-engineered trigger profiling device that, due to its capability to read microscopic movements in the trigger pull with such profound resolutions, it's said to be able to show you on a screen what we normally try to describe as a feeling. For example, if you've ever heard someone review a trigger and say that it feels crisp or mushy or inconsistent or clean or smooth or any other descriptive adjectives, this machine is actually capable of capturing that quote-unquote feeling and displaying the results for you to see digitally. The tool is fairly simple to use. Basically, the gun sits in the rest. There is an arm that comes out and into the trigger guard, and when you hit the button, a servo motor pulls the trigger while the sensor captures the data and a chart is created in real time. Now, I won't go too heavy into the detail about the machine itself because it's a science of its own, but for the purpose of this video, that is the general idea behind how this works. Okay, one last note before I begin the test, and that is the parameters I will use when testing the triggers, because some of these triggers are sold as a standalone drop-in part, and some are sold as parts of kits, which may include additional parts. So in order to do the tests fairly, I have set some rules or parameters that I will use. For example, when a trigger is installed, no other parts or components will be installed with it. For example, Apex sells a kit that includes a trigger bar and an over travel stop bushing. And GRAYGUNS sells a kit with a new sear, a polished safety lever pin, and some new springs. And all of those things will be excluded when I'm testing. I'm only going to be testing and installing the trigger itself, so we can profile the trigger on its own merit. Now, there are many triggers that have pre and post travel screws, and for those triggers, I will be tuning them. However, I will first be contacting the manufacturer and having them walk me through the tuning process, and this way I tune them only to the manufacturer's specifications. Now, this leaves my own experience and bias out of the results as best as I can. The P320 pistol setup will have each trigger installed on the exact same factory FCU, and thanks to modguns.com for generously supplying the parts, I'm able to simulate a brand new firearm by fitting the FCU with all brand new internals, including the striker itself. And last, in order to keep this organized as best I can, I will begin the test with the SIG Sauer triggers and then proceed with testing the rest of the triggers in order of manufacture in alphabetical order. Okay, let's start. Okay, so moving on, the last thing I wanted to explain is the breakdown of the results we saw in the tests, because some subscribers may be curious as to how to take this graph and then transcribe what they see into what's actually happening in the FCU. And for this, I felt it was best to demonstrate that information with a 3D model visual of the mechanics going on in the P320 as the test is being performed. And hopefully that will help answer any remaining questions you might have. So each trigger profile had these categories: free play, take up, total take up, the wall, creep, distance to break, over travel, reset, total trigger travel, peak force, and lock time. And I'm not going to go too deep into defining some of these because chances are you know the basics of trigger travel already. So I will stick to defining those categories that may have you wondering why the graph is presented the way it is. Starting with free play. So in free play, the trigger will be engaged by your finger. The trigger then forces the trigger bar to move, which of course also includes the trigger bar spring. And pretty quickly after that, the trigger bar will slightly move the safety lever in the FCU. And therefore, if you look at the graph, what you see is this slight increase in pull weight that is the accumulation of those three components moving. But after free play, you also see that there is another slight increase in pull weight, and that is the moment the safety lever engages with the striker's lock lever. And so when the safety lever begins to push up on the lock lever, we transition over to what I label as take up. Now, take up is defined by the movement of the trigger bar, safety lever, and the striker's lock lever up until the trigger bar touches the sear itself. The increase in pull weight you see here is essentially the added weight you need in order to begin to compress the spring that pushes down against the striker's lock lever. Therefore, when you add both free play and take up together, you get the total take up. Now, the moment the trigger bar engages the sear, you begin to calculate the wall. And here you clearly see a massive jump in the pull weight required to begin pulling down the sear. And so for the most part, this part of the trigger profile will be relatively smooth and fairly uneventful up until you get to the peak of the wall or the end of the wall and you transition over to creep. Now, during creep, a few things are happening. For starters, the lock lever is almost at its highest point, but also by this point, the safety tab in the lock lever is high enough for the P320 to fire anyways. The sear is also almost fully down, and so the only thing preventing the P320 from firing is the hook at the back of the striker and the remaining surface area of the sear. Where during creep, the surfaces of the striker's hook and the sear are essentially grinding against one another as you slowly pull back that trigger. And so what you're seeing in the graph is this textured or bumpy reading. Now, keep in mind that there's not much that the trigger itself can do to smooth this out because this has more to do with the two parts touching than the trigger's behavior. But depending on the trigger's geometry, if the trigger's angle makes it so that the creep is longer, it is possible that the bumpy texture can be spread out over a longer distance. And so therefore that felt creep can be smoother. But this is a trade-off to consider because most people want less trigger travel and not more. So this definitely can go down to personal preference. Now back to the chart, as you add up total take up, the wall, and creep, you get, of course, the distance to break. Then immediately after the break, of course, is the over travel. And over travel is going to be the distance the trigger travels from break to where it makes a complete stop. But since most people understand over travel, what I really want to highlight here is these sharp jumps that we see on some of the trigger profiles immediately after the break. And those jagged lines are representative of the striker bottoming out and impacting the inside of the slide when the striker is released, causing these vibrations that are then picked up by the trigger scan sensor. So this is not something that is controlled by the trigger itself. Therefore, it's not something that we would associate with the manufacturer's design. So keep this in mind as you review the graphs. Okay, so the last things I want to talk about is both peak force and lock time. Peak force is just pull weight, and the trigger scan essentially can map and log the highest pull weight experienced by the sensors, and it also has a pretty high resolution reading. So therefore, you can see peak force is noted in 3 decimal places, which, to be fair, is far more precise than anyone can humanly detect with their finger, but it's still nice to know the specifics. And last, the charts show you something called lock time, which although it's very interesting to see or know about, it's not something that will be overly helpful to you here, since this is a stock striker and therefore the readings are going to be generally all the same. But lock time is a reading that the trigger scan can make, and it tells you the exact timing in milliseconds that it takes the P320 from the point of break to the striker physically impacting the primer. Now, if I was tuning this P320 with competition springs and lightened or heightened spring tensions on the striker, then this would be more helpful, as you could see the impact those modifications make. But for now, I included this information because, of course, I couldn't help myself, and I really was curious to see what the average lock time would end up being over all 28 triggers. Okay, so those were all the P320 triggers, and I should make a small note here for those that might be curious about this. Due to Sig Sauer's apparent history of continuously making slight alterations to the product line and then using a new part number to reference those changes, it is entirely possible that you can find many more iterations of a trigger than what I have here. For example, here are a few flat triggers, and although they all look the same, if I take these two triggers here, which visually look completely identical and even have the same manufacturing stamps in the back, but if you look closer at the flared walls of the rear of these two triggers, you can see that the walls are much thicker in this iteration. So in trying my best to avoid redundancy and therefore testing 10 of the same triggers simply because they have different part numbers on the package, I avoided testing every trigger unless it had a significant change implemented into the design. So just to reiterate, yes, there are definitely more variations of some SIG factory triggers, but I did not feel it was necessary to include all of them because doing so would not add any value to the video. However, I did include all the factory triggers that you are most likely to run into at the time this video was made. I want to quickly thank ModGuns, formerly SigSauerParts.com, for once again supplying me with the required parts I needed to make this video. And I also want to sincerely thank Scott over at Skips Guns on YouTube for lending me some of these triggers that you see here today. I think I left him with no triggers for a while, so I felt that he deserves a genuine shout out. And last, I want to thank all of you who have subscribed, commented, and supported this channel from the beginning, as we now have hit the 1-year mark and we've blown past quite a few milestones in such a short period of time. So I'm glad to have an opportunity to be able to thank all of you for your support over the last year. Okay, that's all I have for you today. See you soon.